Hello, Krishna. I'm audible.
Yes, sir.
All right.
All right.
Okay. So, Krishna, in the last class, which topic we covered? Hello, audible. Kirtana, please let me know if I'm audible or not.
Third lamp, Peter.
What happened? I'm not getting your voice properly, Kirtana. Kirtana, is my voice lagging a lot? Kirtana, I'm audible. Please let me know first.
Yes, sir.
Yeah. So I'm saying, okay, fine. So, Kirtana, look, some of the instruments we had already discussed. Right? So, if I just take a look at the instruments which we have discussed. Electrical measuring instruments. Okay, so first we will be discussing about a potentiometer. Okay, we can actually talk about some meters. This will be the second. First is going to be meter scale. Okay, okay, Kate, now do one thing. I'm just showing you first problem. Okay, the problem is um, All right. So, Kirtana, look, in the last class, we talked about galvanometer, right? Uh, did you understand the principle behind that? Kirtana, I'm saying in the last class, we talked about galvanometer, right? So, have you understood the principle behind that? Not sure whether you are clearly wrong. Kirtana, I'm even audible to you or not? So, Kirtana, today we are going to discuss about measuring devices. Okay? In this measuring devices, basically, we have galvanometer first. Okay. If I have to make the diagram of this galvanometer, it looks like there is a circle over here. This is a coil. How actually this coil looks like? You will be having a bar magnet over here and another magnet over here. Okay, and there's a center. This is a coil. Thing like this. Diagram will look like this. Okay. So because look, assuming this to be north, this to be south, right? So you know, Ketna, which kind of magnetic field you are going to get. Ketna, please first of all on your mic, okay? Turn on your mic first. Hello, Ketna. I'm audible. Not please let me know. Okay, okay, just rejoin it once. So yeah, Kirtana, now is it audible? Hello, Kirtana, is it now audible?
Yes, sir.
Okay, so yeah, I was saying about this part. This is your basic. I'm again teaching the galvanometric part, okay? So if you don't understand in the last lecture, no worry. So look, here I have this kind of curve, right? So if there's a north, if there's a south, actually the magnetic field goes from north to south. Okay? This is the way, but that is not the topic of discussion for us. Okay. So what happens is here now over here is basically in this galvanometer, whenever you are going to provide what I can say current, how you are going to say this coil will be having a lot of wires. So assume this is one wire, this is another wire, okay? And because this, okay, let's go back a bit. Assume there's a current going I into this way, I current. because it is going inside, so I will come back also. Okay? This is the case. If I is going inside and coming back to you also, so what will happen? It is going to move. Okay. So what I can rewrite it. Uh, it is used. It is used to detect. Ideally, it is used to detect the direction of current. Okay? Direction of electric current. Yeah, it is used to the electric current. Okay? This is one of its prime requirement. This is one thing. Okay. So how it is actually measuring your electric current? If you just have to discuss how actually this is working, I think it's to- when current is passed, the coil deflects due to presence, sorry, presence of magnetic field, okay, and electric current. So depending upon the value of current, if more the current is there, more it will deflect, okay, electric current, it will rotate, okay. The problem is, Kirtana, look, this galvanometer part, the actual working of this chapter is taught in the next chapter, magnetism, okay. But we have not discussed the magnetism, so we'll just discuss a basic principle of it, okay. Let's go further and talk about the principle. What is the basic principle? Okay? So principle is basically whenever you pass a magnetic, basically whenever you pass a current through a coil which is in the magnetic field, when current is passed through a coil in presence of magnetic field, in presence of magnetic field, okay, then the coil experiences a torque, okay, experiences a torque. This is what actually happened. In your grade 10th, you might have seen this kind of structure that this is north pole, this is south pole. Okay, there's this kind of coil. Current is going inside, current is going outside. Okay, this is kind of this thing, this kind of this, and this kind of this thing. So we say there's a magnetic field in this direction. Okay, so when current is going this way, so assume this is a axis rotation, where it actually rotates. Okay? So uh, this rotation is directly proportional to amount of current. Okay? Amount of current passed through it. Kirtana, any doubt is there with respect to this topic?
No, sir.
No doubt, right? Understood what is actually your
Yes.
magnetic field and coil experiences a dot, I think should be dot. All right. So if there's no doubt, I think we can move further. Yeah. Also when the torque experienced by coil is nothing but magnetic field, okay, cross B. This is magnetic field. Okay, sorry, actually. This is magnetic. This is actually magnetic field, okay? And this is your, what is it? Magnetic moment. Just like we have dipole moment, similar to there's something called magnetic moment. The formula of M is current multiplied by area vector. Current and area vector. These things, though, even if you don't understood this part, just remember something okay, about it. There is a lot more discussion is there in the magnetism chapter. Okay, so as I said, if you see carefully, Kirtana, I can actually, if I say this is the first equation, if I say this is the second equation, from equation first and second, what I can simply say that the torque is equals to I times of A cross B, right? Finally, you can also call it as I times of AB of sine of theta, or in other words, MB sine theta. Both things are there. So if you see carefully, if I say B is constant, area is constant. Generally, if there's a coil you have, then area and B is constant, right? We are not changing your north pole, south pole, we are not changing area. So in that case, you can directly say the torque is directly proportional to I. Okay. Therefore, how actually it works? This is a coil. Okay. In this coil, we have a pointer. Okay. Assume this pointer is right now at the zero scale. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. If you provide some amount of current, okay, whenever you because look, when you increase your current, it is going to rotate by some angle theta, right? Rotation is theta. It is dependent upon I. Okay, more the value of I, more this theta will be there. Is it clear, Kirtana?
Yes, sir.
Okay, due to deflection, due to deflection, it is known as deflection type meter. Deflection type measuring instrument. Okay. Kirtana, if you have any kind of doubt, please let me know. We have done all these things so far. Okay, any doubt till here?
No, sir.
Okay, so whenever you're solving the problem, you don't have to make this galvanometer as a coil. Okay, so this G representation of your galvanometer. Representation of galvanometer. Okay? All right, so in a very single note, this is your G, this is your current IG. Current IG is basically, let's write it, IG, RG, resistance of galvanometer, resistance of G, current THRO is used through, sorry, current through galvanometer. That is. So if I ask you what is the voltage across, VG, that you will simply call as IT times of R. Any doubt till here, kids? Now?
No, sir.
I hope no doubt is there. Let's move further. Okay, the most important point to remember mm, in uh, in galvanometry, amount of deflection is proportional to current. Okay, I hope till here you don't have any kind of doubt. All
No.
right, kids, now let's no doubt. Right? Let's move further. Okay, so let's talk about nanometer. Ammeter is not nanometer. It's just nanometer. Ammeter. What is it? You can say that ammeter is a device which is made up of the galvanometer itself. Okay? By galvanometer, we measure the deflection in your current. Okay, how your current is changing, what is the direction of current, and all these things. Okay, what ammeter does measures large electrical. Okay? Why we are not saying small electrical? Because for very small electrical, we have another device. Okay, so how we do shunting? Shunting is a process. What is this? It's basically the process of in which a small resistance is connected in parallel with high resistance. Okay? High resistance. High resistance shunting. Okay. So a process, if you have a small resistance and you are connecting it with a parallel, assuming this is a small resistor, maybe RG, you are applying a very small, sorry, this is a resistance. Okay? What you are doing, you are just applying a small, very small current R across your RG. Okay. This process is known as shunting. Okay. And let's make it as R. This is R. So when small current is applied, when small resistance is connected uh, in a parallel with the galvanometer, yes, meter, then galvanometer, then galvanometer acts as ammeter. Okay. What is ammeter? A device which measures the current. Okay, let's see here now how it actually measures the current. Okay. So assume that I'm saying there's a current, a maximum current. Okay, look, a maximum current. Because the galvanometer will be like a meter, simple meter. Okay, which will be shown like circle over here. In this, you will be having another small circle. Maybe. Here you will be having a from here you will be having a needle, maybe just like this. Okay? It will be pointing to some numbers, maybe 1, 2, 3, 4, 5, 6, 7. Initially, this you can call it a zero. Initially, it will be zero. Whenever you are passing a current, this is going to deflect to this. So this will be maximum, max, and this is the minimum. Okay. So whenever assume that there's a wire. Okay, what I'm doing is I'm just applying the galvanometer. You know, in general galvanometer, the current is going to pass, but you don't know how to measure the current, right? But what we can do is we are adding a shunt resistance across it. Okay, shunt. Now what happens? This whole thing acting as an ammeter. Okay, galvanometer, shunt resistance. Okay, that is the thing. So if assume that this is the maximum current I which is going into the circuit. Look, this is the current in the circuit. Maybe this is a whole big circuit you will be having. From here, this I current is going. Okay. So you know because this is very low resistance. This is very high resistance. Okay. So the majority of the current is going to pass through this, right? Oh, sorry. Majority of the current is going to pass through this. So you can say the current which is passing from here is that is IG. Okay. So you know potential across this A point and B point is same, right? So what you can say is VAB is equals to IG times of G is equals to I minus, because look, whatever the current pass through here, the rest is passing through the S, right? I minus IG times of this. I minus I times of G total of this. So this is what you are having if you resolve this equation. The S will be coming out as IG times of capital V divided by I minus IG. If you want to calculate what is IG and what is just so IG you can also calculate in a way that you know the total current is this much, right? What is the current passing through this much? That will be nothing but total current. Multiply the other opposite resistance. You are checking the current passing from here. So this S divided by sum of both. From where we get this equation? We have already seen this equation from the current divider rule, right? What is the current divider rule? If I is passing here and resistance R1 is there, I1 uh, R2 passing here is I2. So what is I1? I1 is nothing but R2 total I divided by R1 plus R2, and here I2 will be nothing but I R1 by R1 plus R2. This is the whole of the crux. Any doubt, Krishna, till here?
No, sir.
All right. So if I ask you what is the in this case, resistance resistance of ammeter. What is the resistance of ammeter, Krishna? RA. What is the net resistance of ammeter, Krishna? Please let me know.
Resistance of galvanometer in parallel with shunt resistance.
Krishna, can you hear me now? So I can simply write as RS in parallel with RG. Is it clear?
Yes,
RS RG divided by sorry. Look, somewhere I have written SG, somewhere I have written S, somewhere I have written RG, RS, okay? RG and RS. Uh, so don't get confused with this part. So this will be RS, RG, and RS plus RG. Okay, that is the thing. Any doubt till here?
No, sir.
Okay. All right, Kirna. So I'm just giving you one problem. Please look into it. Okay. So this is an example. The example is resistance of a galvanometer. Resistance of galvanometer coil is 90 ohms. Okay. When it is connected, when it is converted into ammeter, then current is galvanometer is 10% of main current. Okay, this is the thing here. So, right. So calculate the shunt resistance. Okay. So yeah, Kirtana, please look into this problem. Try to solve it. Kirtana, try to solve it and get me the answer for this one.
Yes.
Uh, if you have any kind of query like what is given in the problem, something you want to ask, please feel free to ask. Okay? Okay, Kirtana, like in today's session, do you have any kind of doubt in ammeter, galvanometer, or something? Or one more thing, please do it fast because I wanted to cover the voltmeter also itself. Because the both are very small topic, I wanted to cover voltmeter also. It should not be taking too much time to think. Okay?
Is it 10 ohms, sir?
Yeah, that's a 10 ohms. Okay, makes sense. All right, Kirtana. So I hope you don't have any kind of doubt. I'll just try to give the solution for this first. So look, the problem says you are given a galvanometer having a 90 ohms of the resistance, right? So the problem gives you RG is 90. RG given is 90, right? Yeah, RG is given as 90. Okay, so if RG is given as 90, okay, what other things is given? When it is converted to ammeter, then the current, okay, we have converted this into the ammeter. The current in the galvanometer is 10% of the main current. All right, so assume that this I was the I, okay, and in this RG, it is basically one tenth, okay, 10% of the, you must have inserted the sum. This is your animator, okay? So what happens is this IG is basically 10% of 10 by 100 of your total I, right? So you can simply say I by 10, right? So from here you can simply get the value of I is equals to, what is it? IG times of, sorry, you can, in better you can write this 10 times of I. This is what you can write. Now what we have to solve? Nothing. S, we already know the formula for S. What is it? RG, right? You can simply apply this formula. Yeah, this IG and that. So if you go back, I minus IG, right? So you know the value, right? If you don't know, you no problem. IG, you don't know. Let it be. G divided by, what is I? 10 times of IG minus IG. So this whole thing is actually going to come out as 90 divided by, what is it? 9, right? So 10 times of, is it clear?
Yes.
Okay, so I hope we can move to the next topic.
Yes.
Voltmeter form. I will, I will. Okay, Ketan. So now the topic comes up is voltmeter. What's the main difference in voltmeter and this ammeter, Ketan? Yeah, Ketan. I'm asking like what's the main difference between voltmeter and that ammeter? You can call this
It's
as galvanometer of high resistance. Why we are calling galvanometer of high resistance? Because look, what actually happens, let's see. If you could remember in the animal, we are adding a very small resistance, right? So whenever you are adding a small resistance to the parallel, in parallel with bigger resistance, the whole value goes down. Okay, yeah,
yes.
yeah. So this is the case. Okay, basically, in case of galvanometer, basically, when I wanted to make it voltmeter, what actually I wanted to do, I wanted to measure the how much voltage is there, right, across. So assume there's a current going. Okay. In general, if you could remember, we talk about high resistance. It means to say the whole of the current will be passing. Assume, let's say this is my circuit. Okay, there's a normal resistance is over there, and I wanted to calculate what is the, this is battery. Okay, sorry, this is battery. I wanted to calculate what is the potential across this. I really don't have any option. Okay, what I should do, I don't know. But I know one thing. If I take a galvanometer and place it over it, and if I directly attach it, what will happen? It has some high resistance, and this has some value itself, right? So what will happen? Some part of current is going to go in this way, and some part of the current is going to get this way. Okay, this is I, this is IG, okay, and this is going to be your other thing. Okay, so this whole thing may be acting as a volt ammeter or something. We are going to get an unnecessary value. What we are going to do is, first we will convert this galvanometer into a voltmeter. How we are going to do? Yeah. So look, place a galvanometer and place a very high resistance along with it. Okay, what's the benefit of placing a high resistance? Assume 100 ohm resistance is going, 100 ampere current is going very high. Okay, I don't know this. If you have very high resistance over here, you know, because the potential across this point is going to be same, right? So I into R and I into R is going to be same, right? IG and I minus IG or something. Okay, let's say this I in the resistance and IG. So because this is very high value, okay, and this is a relatively lower value. So to make them both equal, this value is going to be very less and this value will be very high. So if you keep your current to be very high, basically if you keep your resistance very high, what will happen? The majority of the current will get passed through it. Okay? Majority of the current is going to get passed through this branch itself. Okay, very small amount of current is going to get passed from here. Now you can call this as voltage. Okay, how we are going to actually measure the things? Very simple. The total current is I. I wanted to know what is the potential across this. What we can do is we will be knowing what is the IG. You can say that potential across these A and B is same, right? So VAB is same. Then what you can say? I minus Ig, because in this Ig the total current is given. What is that? I minus Ig multiplied by your resistance R. Okay. Actually, no, this is not a way we are supposed to measure. Okay. This is just a voltmeter which we have to actually measure. Right? So assume potential is V. Potential is V. Okay. Now you can say that this voltage should be equals to whatever the current Ig is passing multiplied by this G plus Rs, this shunt resistance, right? Ig times of Rg plus Rs, shunt resistance or something. This is what the current is about. So if you see carefully, let's rewrite the equation. So V by Ig. What you are going to get this by doing this Rg plus Rs, right? And what is your Rs in this? You can say that these are the resistance of your voltmeter, but we don't have to write it in this one. What is Rs? We have to calculate shunt. So that will be V by Ig minus Rg. This is the thing. And this whole thing is resistance of voltmeter. Resistance of voltmeter. Okay? Is it clear, kids? Now this is basically the current which is passing through. Okay? This V is the amount of current which is passing through this branch. Any doubt till here, kids? Now?
No, sir.
No doubt, right? Okay. All right. So let's try to solve some problem on this also. This we'll call this as the last topic. Maybe. Resistance of galvanometer coil is 100 ohms. Okay. It's full deflection. I will tell you what is actually the full deflection. The full deflection has same meaning in case of ammeter or voltmeter or galvanometer. Okay? Full deflection current is 1 milliampere. Uh, calculate fire resistance to convert into voltmeter of range 5 volt. Okay, basically, sorry. You are given basically a galvanometer having deep configuration. Full deflection is also given over here for this amount of current. Okay. What it wanted to ask is, it is saying that you have to calculate required. Okay, let's make it required. Required resistance. It is saying that you should be you have to create. You are given a galvanometer G you have to convert this into a voltmeter, okay, such that it can measure 5 volt. So please do it. Okay, try to solve it and get me the answer. Yeah, Kitna, you're solving this problem.
Yes, sir. Sir, is it 4,900?
How much?
4,900.
Yeah, it's 4,900. Yeah, it's correct. Actually, it's 4,900. Um, so do you want solution for this one? Kirtana, do you want solution for this one?
No, sir.
No. Okay, so, yeah. Okay, let's do one thing. I'm not going to write the whole problem, okay? It takes actually time. It will be better if you just sorry. I'm directly writing it. You're given a resistance of galvanometer, RG, 150 ohms. So, and deflection current is given as, okay, deflection current is deflection current 20 micro ampere. Look, please remember the unit per division. This is written. Number of full scale division is 100. Okay. What you have to calculate? Uh, calculate resistance to convert it into to convert this into a volt. This is what the problem is. solve this problem and get me the answer fast.
So voltage.
Yeah, Ketna, how much you have got?
What is the voltage?
Wait, you're not audible properly.
What is the voltage?
So what is the voltage?
Yes.
8 volt, 8 volt, sorry, 8 volt. Into voltmeter of range 8 volt. That's it. All right, you try to solve this. I'm writing another problem. Okay, let's say this. What should we take it as a last?
Sir, is it 3,940?
300, 3,000.
940.
Wait, just put that into the chat, please. 3,940 is not their answer. Quite, what I can say. You are near to it, but it's not correct. You can try it once, but the answer for this one is okay. I'll just give the solution. Okay? Let me try once, that's fine. Okay, so Ketna, just to tell me what is given in the problem. Just tell me what you understood and what is given in the problem.
IG is 20 micrometers per division and multiplied it with 100, sir. 20 into 10 to the
Okay,
power minus into 100.
all right. So basically, for each division, for one division, what is the current? What is the deflection basically? Deflection current is basically 20 per division, right? So you can say if this, let's say this is a galvanometer, okay, and this is a 1, 2, 3, 4. Although there's 100 and this millimeters. So if you increase the current by 20 microampere, okay, this is going to move from here to here. If you again increase 20, it is moving here. So this is what the division actually means. Okay? Here we have the total 100 divisions, right? That's it. Okay. So this for one division you are having this thing as 20 microampere. So for 100 division, what will be there? Okay. So what is current IGs? IG. IG is nothing but whatever the 100 is. Basically IG I can say the maximum current because you wanted to look out the what is the maximum value you can have. Okay. So that is 20 into 10 to the power minus 6 into 100. Right? I can say this. Makes sense. So this whole thing, if you solve it out, you are going to get 2 into 10 to the power minus 6. Because what actually wanted to do it, now you just have this kind of circuit, okay? This kind of voltmeter was there. Okay. So it was saying uh, for in a maximum case, you wanted to measure, okay, it is given that if you increase current by 20 ampere, this thing, it goes by one deflection, okay, one deflection. You have 100 small divisions, right? By using these 100 divisions for these particular range, you wanted to measure 5 voltage, right? That is what you wanted, 8 voltage basically maximum. So what you can simply do is now you know the range RH, right? What should be the voltage? Voltage is already given, right? What is it? 8,000 volt. Sorry, 8 voltage basically. So it is 8 volt divided by what is Ig given? Ig is given as this number. So you can write 2 into 10 to the power minus for a maximum voltage, because if the current is max, you can say for max volt calculation, just take the maximum current. So this is what minus Rg requirement. So you can say 8,000 divided by 2 subtraction Rg. What is Rg? 150. 4,000 minus 150 gives you answer as 8,850. Clear, Ketna? Any doubt? Yeah, Ketna, if you don't have any kind of doubt, I'll end the session by this, okay?
No doubt.
No doubt, right? Okay. So yeah, Ketna, that's all for the today's class. In the next class, I will discuss the rest of the three instruments, okay? Potentiometer, weight sounders, and one more is there, okay? So yeah, Ketna, that's all for the today's class. I will end the session by this. So yes. Yeah, Ketna, so that's all for the today's class. I'll end the session by this. Okay? You can leave. If you don't have any kind of leave, you can take an exit.